We're going to graph a transformation of a radical function. First, we want to figure out what this parent function is. And this is a square root because we don't see any number over here. So that means it's a 2, a square root. So when we're coming up with our square root parent function points, try to picture that graph. Remember, we can't square root or even root negative numbers. So we can start at 0, square root of 0 is 0, square root of 1 is 1, just like any even root. But then if we want to think of one more point to square root, 2 would give us a decimal, 3 would give us a decimal, but square root of 4 is 2. Now we want to think about what the transformations are. Inside the function deals with horizontal transformations, and it also is the opposite of what it looks like. Outside the function is vertical, and you don't have to switch anything around. So that plus 1 means it's shifting up 1. We're multiplying by 2, so that's vertical, because it's on the outside of the function, stretch by 2. And then the negative, again, that's a vertical change. But if you're changing vertically, you're reflecting across the x-axis, but your y's are going to be changing. And then if you look inside the function, the plus 4, it's a horizontal shift, but we have to switch it, so it's going to be left 4. And then the 1/3 that's being multiplied inside the function, remember it's inside, so that's going to be a horizontal transformation. It's going to be a stretch or shrink because it's multiplying, but we're also going to flip it. We're going to change it. So the 1/3 actually is a stretch by 3, horizontal. So the x transformations, we're going to go 3x minus 4. And then the vertical transformation, we're reflecting, multiplying by 2, and then we're going to add 1. So then we can go to our previous table. 3 times 0 is 0, minus 4 is negative 4. And then the y is negative 2 times 0 is 0, plus 1 is 1. And then you have to be careful when you connect the points. So you need to think about what the parent function graph looks like, if it's more of an S shape, or if you have a starting point and then it keeps going. And so that has to do with if you have an even root or an odd root. This is a square root, so it's an even root, meaning it has a starting point and then it keeps going. And if you look at your graph, it might be hard to tell, but this was our starting point on the parent function graph because that's what the graph looks like. So that specific point transforms to that point, meaning this is our starting point, and we can extend it from there.